Use Cramer's rule to solve this system. All right, in order to use Cramer's rule, I got to turn this into a matrix. So an augmented matrix would look like 2, 3, negative 5, 1, 1, 1, negative 1, 2, 0, 2, 1, 8. Since this is the only thing I'm going to be dealing with, I'm going to pull that up and just deal with this matrix. So Cramer's rule says if I want to solve for x, I need the determinant of my x piece divided by the determinant of my variable piece, and I'll talk about that in just a second. Y is going to be the determinant of y piece over this, and z is going to be the same thing, but with z there. Okay, so since I'm using the determinant on every single one of these, the determinant of my variable piece, this thing, I need to find that first. Now this is going to be the determinant of just my variables and not my constants. So this is going to be the determinant of 2, 3, negative 5, 1, 1, negative 1, 0, 2, 1. So that's what it's going to be. Now, in order to find the determinant of this, I can use any row or any column. So I'm going to use this one because it has a 0 in it. So that becomes 0 multiplied by its determinant, its minor, and I don't care about that because 0 times anything is 0. Then it's going to be subtract, since they changed signs, 2 multiplied by its minor, and if you don't remember where its minor comes from, I pretend that the row and the column of that 2 don't exist, and what's left is going to be its minor. So 2, 1, negative 5, negative 1. So 2, negative 5, 1, negative 1. And then I'm going to add it to 1 times its minor, which is going to be 2, 3, 1, 1. So this gives me 0 minus 2 multiplied by this guy's determinant, which is going to be negative 2 minus a negative 5. So that's going to be negative 2 plus 5, which is going to be 3. And then plus 1. And the determinant of this 2 by 2 is going to be 2 minus 3, so that's going to be negative 1. So this is going to be negative 6 minus 1, which equals negative 7. So I'm going to make a note up here that this equals negative 7. So now we need to find d sub x determinant. What that's going to be is going to be the determinant of the matrix is if I take this answer row and replace it with my x row. So it's going to be the determinant of 1, 2, 8, and then everything else stays the same. And if you see what I did, I replaced this with this, and then these stayed the same. So now I have to find the determinant of this, which is going to be a little harder because there's no zeros, which is not fun. So this is going to be 1 multiplied by its determinant. So 1, negative 1, 2, 1. It's minor, sorry. And then minus 3 multiplied by 2, 8, negative 1, 1. And then plus a negative 5 multiplied by its minor, which is going to be 2, 1, 8, 2. I forgot to explain that I'm using this row, mainly because if I can't find one with a 0, I just use this one by default. So now I have 1 multiplied by 1 minus negative 2, which is going to be 1 plus 2, which is 3. So this is going to be 3. Minus 3 multiplied by 2 minus a negative 8, so 2 plus 8 is going to be 10. And then plus a negative 5 multiplied by this determinant, which is going to be 4, minus 8, which is going to be negative 4. So if I put these together, you get 3 minus 30 plus 20. Negative 30 plus 20 is negative 10, plus 3 is going to be negative 7. So, going back up to here, I know that x is going to be this, which is negative 7, divided by this, which is negative 7. So I get negative 7 divided by negative 7, which equals 1. So I found x equals 1. Now I got to find my determinant of d sub y, which is going to be the same idea, but I'm going to take my answer column and replace it with my y column this time. And this will be the determinant of 2, 1, 0, 1, 2, 8, negative 5, negative 1, 1. And now, since this one has a 0 column, I'm going to use this column for my to solve this determinant. So that's going to be 2 multiplied by 2, negative 1, 8, 1, minus 1, this is going to be 1, negative 5, 8, 1, and then plus 0 times who cares. So 2 minus a negative 8, so 2 plus 8 is 10, so that's going to be 2 multiplied by 10, minus 1 multiplied by 1 minus negative 5 times 8, so that's going to be negative 40. So it's going to be 1 minus a negative 40, so 1 plus 40 is 41. Which then this equals 20 minus 41. 20 minus 40 is negative 20, and then I need to subtract one more, so that's going to be negative 21. And so d sub y is negative 21. So if I look back up here, y is going to be negative 21 divided by negative 7, which equals 3. So now I found y. Last piece. So let's find the determinant of d sub z, which is going to be the same idea. I'm going to take this and replace it with my z, which is going to give me the determinant of 2, 1, 0, 3, 1, 2, 1, 2, 8. And I'm going to use this column again, because it has a 0. 2, and then 1, 2, 2, 8. And then minus 1, which is going to be, this is going to be 3, 1, 2, 8, plus 0 multiplied by who cares. So this is going to equal 2 multiplied by 8 minus 4, which is going to be 4, minus 1. This is going to be 3 times 8, which is 24, minus 2, so that's going to be 22. So this is going to be 8 minus 22. And 8 minus 22 is going to be 14, negative 14. So z is going to be negative 14 divided by negative 7, which ends up being 2. So my answer is 1, 3, 2.